Actually, that's 9 o'clock, so let's get started. So, welcome to this session entitled, Don't Let Your Permissions Be Hijacked. My name is Erland Sommarskog. I live in Stockholm, where I work as an independent consultant, and I've been MVP for SQL Server for many years now. The way to get in touch with me is by old-fashioned email, sql@sommarskog.se, and you're more than welcome. If you have anything that I don't answer today and you want to, please just drop me a line, and anything else but SQL is also always welcome. It's always a change to all the spam I get. I also maintain a website, sommarskog.se, which you can see as well as small collection of large articles that goes in depth in a couple of topics. As a matter of fact, one of these articles is called Don't Let Your Permissions Be Hijacked. I put that one up like 2 years ago, but I felt that this was something I wanted to raise an awareness of, so I also decided to make this into a session. Slides and script for this session is available on my website, sommarskog.se/present. By the way, I should warn you, I would recommend that you download it because there will be a few links in the deck. Now, one thing that will be interesting when you download the deck is that the background is actually green, but I had to change the background because of the funny light in this room. Oh, for the people who are online, they got purple. Well, some people say it's pink. I think it's purple. It's very weird. So, then you might think, what is he talking about? Permission hijacking? I never heard about that. Well, so this is what my thought about the whole thing. So, you have a person with, less permissions than you have, but some kind of elevated permissions. That makes you unknowingly run code that uses, or rather abuses your permissions to perform actions that, are advantageous to the attacker, but you would certainly not agree to run if you knew that you were running them. And you may think, how is that going to happen? Well, we're going to see that in a second. But before we come to that, I'd like also to get your mindset in the right mood. Because you might be saying to yourself, but wait, this is just too fantastic. That is not going to happen. Please. When it comes to security, there is no such thing as too unlikely. If an attack can be performed, it will be attempted sooner or later in some place. And you don't want that place to be your workplace. Because all depends on the stake. If there is enough to gain, or if the attacker is desperate enough, then let's try this. And what may the attacker want? Oh, they seem having fun in that room. So what may the attacker want to do? Well, perform advantageous updates. Well, the classic example, going into the employees table and double your salary, but it could be something else. Or steal data, maybe to sell it on the darknet or sell it to a competitor, or maybe use that when you're going to start up your own business. Or just install ransomware, being in collusion with some of these Bitcoin people out there. Or just make a mess in general. Frank knows that he was going to get the sack any day now, and he's completely pissed with the company. So he's going to leave a surprise and just make things up. And he doesn't really care if he gets discovered because, he's going to leave the company anyway. Also, I like to point out that not all sides are equal. I mean, some places things are very simple. There are the DBAs, the sysadmin people, and there are the plain users who can run through procedures and select and write data to tables, but there's nothing in between. Well, these sites are not very susceptible to these attacks that I will discuss, but see below. I will come back to that in a second on this slide. But then you might also have other places. Well, there you are the DBA, and then there was someone on database level who's like a database level DBA or application admin or something like that. Or there can be developers who are on the DDL admin role or have other permissions to create code. These are the places where you need to watch out. But I like to keep in mind that don't overlook application logins. If we have an application, we can more or less assume that there is an SQL injection hole, sadly, but that's true. So anyway, of course, application login should ideally only have some limited set of permissions, that I will come back to later on. But unfortunately, it's far too common that they run with some kind of elevated permission, and in such case, an attacker coming in through an SQL injection hole could use these to go further into the system by abusing your permissions. And what about developers who write code that gets deployed in this system? I will come back to those towards the end. So this is kind of the agenda. The first part, which is actually the longest, is called the evil DDL trigger and the principle of least privilege. It doesn't tell you that very much, but you're going to see in a second what it's all about. Then I will talk about the DDL admin route, and specifically on DDL triggers. There's a special thing about those. I will talk about the benefit of using sandbox logins and sandbox users. I will talk about permissions that application logins should have and what we can do when they need more permissions beyond that, and that is about certificate signing. I will discuss how we should run application jobs in SQL Server Agent. And the last thing I will discuss is attacks through deployment. By the way, I kind of expect that this session could raise some questions and so on. And if there is questions coming in, I might take those directly, or I might defer them to the end because of the 50-minute format, I'm kind of little tight on time. So the devil DDL trigger. So this is where you're going to see this attack in practice. So we're going to start with creating a database here called app2b. And I'm going to make SA the owner of app2b. That's just very common to do. I don't think this is best practice, but it makes this particular demo more interesting, and I will come back to what I think is best practice later on. Anyway, in app2b, there is an application admin whose name is Debbie owner. So we're going to create a login for her, and she's going to add her to app2b as member of the DB owner role. And then what I'm going to do now, I'm going to apply Debbie owner. I'm going to run this command, execute as login. So rather than logging in a separate window as Debbie owner to make the demo more smooth, I impersonate her, and I will be Debbie owner until I run this command, revert. And, well, Debbie's going to do some work. She's creating a table and adding some data to it. Nothing strange there. Then night falls, and it's my duty as a server-level DBA to run database maintenance. So I'm going to run dbc-checkb. I'm going to back up the database. I'm going to rebuild the index on that one table. I'm not going to do update statistics because that's kind of stupid when I've already rebuilt the index. I'm going to do that. And then, while we're at it, let's check who are the members of sysadmin. And, well, those are the usual suspects. There is SA, there is myself, and there is these three service accounts. Now let's see what Debbie is going to do now. She's going to create a DDL trigger for DDL database level events. That is anything, any DDL command. And if the current user is sysadmin, she's going to do this: use master alter server role sysadmin add member Debbie owner. That's kind of rude, isn't it? Okay. Anyway, night falls again, and I've got to do my database maintenance, and I start with the check2b and back up the database, and then we're going to check who are the members of sysadmin. Well, nothing has changed. Everything is okay. That sounds great. But now we come to the index maintenance. And Debbie is now a sysadmin. She's taken over the machine. So what she did was that she hijacked the permissions of, well, my permissions or the permissions of agent, if this was running from an agent job, and sneaked in to become a sysadmin. Well, that's bad. Well, let's take her out. And let's also try the update statistics command, which we typically also run in maintenance jobs. And she's back, because both of these commands fire the DDL trigger, and Debbie could take benefit of this. Let's take her out, and now, what can we do to protect ourselves against this? Well, let's first think about the problem. What is the problem here? Well, the problem is we have too many permissions. We're going to rebuild, we're going to do some maintenance in the database. But we don't need our server-level permissions to do that. Well, we need the server-level permissions to access the database. But once we're there, we'd like to throw out these server-level permissions out the window, or at least like put them in a little, like in a kind of a bag, and just hang them out the window, and then we can drag them back. But what if we could do that? Well, it turns out we can. It's actually very simple. So we can do this. We can impersonate a database user, DBO, execute as user equal DBO. Then you might say, well, wait a minute, DBO is sysadmin, it's SA. So how could that help? Well, let's try it at least. It did help. Debbie did not make it into sysadmin. But why did this work? Well, we have to look at these two DMVs here called sysuser token and syslogin token. They give you the security token active on database level and on server level, respectively. And on database level, it's very simple. I'm DBO, because I'm sysadmin, so all I'm mapping to is DBO, but that gives me also full powers in the database. On server level, there's a whole bunch of them, because I'm logged in with Windows Authentication, so all my Windows groups turns up here. But there's also public and sysadmin on server level. And you might also see here we have this usage, grant or deny, but all of these two actually deny only. But these means that they're good. These tokens are good for both grant and deny. Now what happens if I do this execute as user equals DBO? Well, on database level now, I also get public and DB owner for some reason. And on server level, well, I'm SA, I'm public and sysadmin. So, but then I'm sysadmin, I can do anything. No, because here, deny only. It's only good for deny. And why is it that way? Well, there is a very important thing when it comes to doing impersonation. What happens in Vegas stays in Vegas. If you're doing impersonation in one context, it's not valid outside that context. If I'm doing because I'm impersonating a database user. Previously, I impersonated a login. So I'm doing this on database level. And why is it this way? Why do we have this restriction? Well, imagine that if we didn't have this, and Debbie could then do execute as user equals DBO, and she would be SA. That would be really, really bad. Then she wouldn't need this trigger. So that's why this works. That's why they have this restriction. Now you might think, though, but wait a minute. Debbie could be smart. She could add this revert command to the DDL trigger. So she's going to try that. And let's see, I'm going to, again, impersonate DBO. We're going to run the index maintenance, going to run the up to statistics. No, that did not work out because revert only counteracts an execute as or impersonation in the same scope. So if there had been an execute as inside the DDL trigger, yeah, then the revert, oh.
Is there an error coming from the DDL trigger? If there was an error.
No, there's no error. Because Debbie is smart. She realizes if the DDL trigger would produce an error, someone might get suspicious. Okay. So that's why she had this trick. And the revert will not produce an error. It's just because revert never produces an error if it's not needed. It's just being swallowed. And I will come back to that on the slide. So the revert is only good for counteracting impersonation in the same scope. So it works here on the script, but it doesn't work to counteract an outer script. That is also very good. This was stuff that came in SQL 2005, and the security people that worked on this in 2005, they were really, really smart, I can tell. Before I leave this demo, I'd like to drop the evil DDL trigger entirely and go back. Just to summarize, so what you saw here is that when running index and statistics maintenance, well, application admin could have installed the DDL trigger that, well, performs malicious actions. And I like to point out now, adding yourself to sysadmin is just one example that it just stands out, very clear that something is bad. But it's probably not the best kind of attack because let's say that the next morning there is an IT audit and someone asks two other members of sysadmin, and what is Debbie doing there? That could get her into trouble. But she could do something else, steal data, or well, yeah, any other kind of evil stuff. Now, the whole thing with this, what it's based on, is something called the principle of least privilege. Now, permission hijacking is a term that I make up myself, but this is an established term. It's also known as POP. There is a Wikipedia article about it, and there's also Andreas Wolter, who is program manager on the SQL Server team, and particularly focusing on security, and who used to be an MVP. He has a good blog post about this as well, because this is all about don't have more permissions enabled than you need for the moment. That's a great thing if you can do that. And in this particular case, it was execute as user equal to DBO. That way we actually did this, just putting out the permissions out the window and then drag them back with the revert command. Now, I'd like to discuss these execute as commands a little more because we will come back to those a few more times in this session, so I would like to give some more details about them. So execute as user, this means runs command as a database user. So that means you're stripped of any permissions on server level. You cannot access other user databases. You can access temp2b and master and also MSDB because they have the guest user enabled. But other normal databases, you're not. You're completely locked out from linked servers. That's good thing to know because that will put us some restrictions when we can use this. And to do this, you need impersonate permission on the user. And of course, if you are in the DBO role, you have that permission. Then we have execute as a login. That means you're running commands as a server login. So in this case, there's no sandboxing inside SQL Server. You can go to any database. There's no restrictions. However, you cannot access linked servers that are set up with self-mapping. Because again, what happens in Vegas stays in Vegas. Your impersonation is not valid in Windows. It's not valid on that other linked server. But if you have a linked server set up with login mapping, no problem, because then you are going to log in as that other user for real. And to do this, you need impersonate on the login, which is a server level permission. And of course, if you're a sysadmin, you have this permission. Now, the revert command is, so that, as I told you, the impersonation is enforced until you execute revert in the same scope. So if you have an execute as in a procedure, you can do revert, and it will counteract that particular impersonation. And if you do execute as inside as the procedure and do not do revert, there will be an implicit revert at the end. Good to know is that if you start the impersonation, for example, will execute as login and then move to another database and try to do revert. No, that is not going to work out. You have to be in the database where you started the impersonation to do that. You may or may not have noticed this, but in my scripts, I had revert in a separate batch. That is not required by syntax, but I very much recommend that you do this, because if you do the impersonation and you have some commands, and then you have revert at the end of the same batch, and that batch errors out. Revert may not be executed, and but you think mentally that it has executed, so you will be very confused. I know, because it has happened to me more than once. Yes. And exactly what Louis asked, if you do one revert too many, it doesn't matter. You will not get an error. It's not like you were doing a rollback transaction one too many, you get an error. But no, too many reverts is just going to be ignored. There is also some variations of this. You can see execute as with no revert. And why we're going to do this, something I will come back towards the end. So, then now you know how to protect yourself against this, but there is a hiccup you need to be aware of and how to deal with. So let's have an illustration of this. So I'm going to restore another database from what that comes originally was creating another server. And then I'm going to move to that database and try to impersonate DBO. But I get an error message, 15,517 cannot execute as a database principal because the principal DBO does not exist. This type of principal cannot be impersonated, or you do not have permission. This is quite confusing, but wait a minute. Why can I not impersonate DBO? Hey, I'm sysadmin. That should work. Well, the reason for this is found here. So we're going to look at, so the owner for the database is actually recorded in two places. It's recorded in owner SID and sys databases, but it's also the SID and sys database principals for the user DBO. And when I run this select, you may know that they are different. So why does this happen? Well, this is because when you restore a database, if there is already a database with that name on the server, the owner will be retained. If it's not, you will be the owner, become the owner of the database. But none of these cases is actually going to change the SID for DBO inside the database. So that's why you get this mismatch. And this is not the only place where you get this problem, because, well, all the cases where you get this problem is related to impersonation. But a classic example, if you're trying to install database diagrams, well, yeah, then you might also get this error. And the remedy to fix is to do this is to change the owner of the database. And while I'm at it, I like to do this by, I think it's best practice. So I think a database should be owned by an SQL login that exists only to own that database. And I don't want to know the passwords. I'm going to give it a random GUID, and I'm also going to disable it. I'm going to create that user, and then I'm just going to make another DB $login, the owner of that database. And now when I run impersonation, everything works fine. And this slide just repeats what I said in the demo, so I will move on and talk a little bit more about database maintenance, because in the demo I did this, well, just running this from Management Studio. In real life, I hope you don't go and writing your own maintenance jobs, but you use some of the existing solutions out there. And I would expect that quite a few of you are already using Ola Halligan's maintenance solution, and if you are in a very good position, because Index Optimize accepts the parameter execute as user, which you can set to DBO or any other user of your choice. So he has it solved for you. He has this protection for you. Now, if there are some people that still insisting about using the maintenance plan in Management Studio, bad news, they don't have any support for this. Because, well, no one thought about this when they originally devised the maintenance plans. If you are using them, well, the DBCC and backup are safe. But if you are also doing index maintenance and statistics maintenance, and you have people that could perform these attacks, you have someone who's DB owner in the database, or it's a developer and so on, well, you have to, well, think for a different strategy, or just move to Ola's solution. And also that this was, so far I only talked about index and statistics maintenance, but let's think about DDL in general. If you are the server level DB and you're also going to work in the database, any DDL in the on database level is dangerous. Creating indexes, creating users, granting permissions, anything. So this means that you cannot use the UI in Management Studio. No, 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 you have to use the SQL commands. Do I send some brave faces now in the audience? Well, okay, you can still use the UI if you stay away from that OK button down here and always use this script button to do things in the database. Because then you can script out in the window and then you can add the execute as user thing in the window. So far, I've talked about attacks against sysadmin, how Debbie, for example, could become sysadmin. But Debbie could also be under attack. So Debbie actually gets an assistant, Dave, who's going to help her with writing the procedures, create table, etc. He's going to work with the application. So Debbie thinks, okay, I'm going to add Dave to the DBDL admin role because I don't trust him to deal with users or that kind of stuff. He's only going to write code. But it turns out that if you come into the DBDL admin role, you also get permissions to write DDL triggers. So Dave, I mean, what? I want to be at least as cool as Debbie, so he's going to add a similar trigger. And, well, maybe he's also going to try to add himself to sysadmin, but he's also at least going to try to, at least going to be DB owner if Debbie's going to do something. So that, yeah, he can do that. That's quite bad. Now, how could Debbie protect herself? Or rather, how can we keep developers out of DDL triggers? Because here's an observation. DDL triggers, they're not part of the application, or at least I can't see how they can be. DDL triggers, we might use these for auditing. For example, what are our developers doing in the database? They don't have any business there. That's my strong opinion about it. So, this is what Debbie should do. She would create a role, for example, call it our DDL admin, or she could also request an AD group to use that. Then she would make this role a member of DDL admin, and then she would run this command, deny alter any database DDL trigger to our DDL admin. So they can do anything that DBDL admin can do except for dealing with DDL triggers. And then she would add developers to this role, not to DBDL admin. Or, of course, you can also may prefer that you only want to have developers to work in certain schemas, etc. But then you're avoiding this issue entirely. And then you might think, but why do this roundabout way? Why not deny DBDL admin directly? And the answer is SQL Server does not agree to do that. And yeah, here's a demo that I'm not going to do, but you can see Dave's attack in practice if you do that script on your own. So far, the attacks has been for DDL triggers. But as you might imagine, that's not the only place. We could use DML triggers as the procedures as well. I mean, Debbie or I might be doing data maintenance in the table. We might do this every day. And all of a sudden, Dave or Debbie has added a trigger that does evil things. And of course, since we're doing this every day, we're not going to go and check if there's a trigger every time. We're not going to do that. It's just going to be not going to happen. Or we might be running some procedures, maybe the part of the application, maybe some maintenance procedures, and all of a sudden, Dave or Debbie has snuck in something on the fourth nesting level that's doing something evil. And again, we're running this code every day, so we're not going and check every time. So how do we protect ourselves against this? Well, if it's only a matter of protecting sysadmin because there is no dev Dave or any developer, there's only a DB owner, well, we can impersonate DBO because then we know that this set of permissions is safe. And if it happen to be the case that we need, let's say we're going to copy data from one database to this database, we can get that data into temp tables before we start the impersonation so we can access that data and then we can move on. Now, but how protect DB owner? How could Debbie protect herself against this? Because she's going to insert data, she's going to run the procedures, but she doesn't trust Dave. So how could she protect herself against this? Again, we have to go back to the principle of least privilege. If she's going to run the procedures, she's going to insert data. She doesn't need to be a DB owner to do that. She only needs lower permissions. So she would do this. She would create a sandbox user. And she would do that without login. This is a very, very powerful thing. You can create a user without a login. And the reason this is great for Debbie is that she does not have permissions to create logins. And also, you don't have to do all the business with password or anything if you only need this on database level. And then she would grant this sandbox user a reasonable permission set. In many cases, this is going to work out, execute to the sandbox user, and then select, insert, update, delete on sandbox user. There might be some interesting situations where this might be too much, but I will not go into those. And then she would just simply impersonate sandbox user. And as a matter of fact, Debbie could play and be the sandbox user for most of the work she does. It's only when she's going to do DDL or create users, that's the only time she needs to back out of that. And then she could do that in a separate window. Now let's say that I'm a sysadmin. As I am a sysadmin, I'm going to do some data main because they ask me, oh, can you please clean up this data in this database? I normally don't work in this database, but they know that I'm good at SQL, so they want some help from me. And then I ask the database owner, oh, do you have a sandbox user that I can use? And I just get a blank stare back because I don't understand what I'm talking about. But I still feel that if something bad happens, I don't want to get the blame. So what should I do then? Well, first of all, if I need some outside data, I need to get that into temp tables. I impersonate DBO with the execute as user. I create the sandbox user without login and grant the permissions. And I impersonate the sandbox user, do the task I need to do, revert back to DBO, drop the sandbox user because since it's just a one-time thing, I don't want to leave that sandbox user around. That's because just as a matter of decency. And then revert back to my true self. So the point is here that, yes, you can do the impersonation in 2 levels, and you need to do this because else if I go in and create the sandbox user without doing this first, yeah, they could have a DDL trigger that goes and hijacks my permissions. That would be bad. Now, what if the work I need to do needs access outside the database? Because with execute as user, I'm sandboxed into the database. So if I try to access another database, I will get an error. And that could be, for example, supersedious that goes to cross-database access or to linked servers. Or it could also be that I said you can get outside tables into temp tables, but that is not always practical because these tables might be very big, and I don't know exactly which rows I want because I need to join things. So how am I going to deal with this? Well, of course, I can do a sandbox, a login that I impersonate with execute as login, or because it's a login, I could, if I prefer that, I could log in a separate query window. And if I'm sysadmin, well, that's very easy because I have all the powers to do that. If Debbie needs this, well, she would have to talk with the server level DBA, hey, permission hijacking. This is, Erland talked about this as bits. I know this is dangerous. I need a login to deal with this. And that I can impersonate also because I don't want to have a separate window for that. Now let's talk about application users and in general. So an application, of course, some applications simply you log in as yourself in the database with integrated security, but it's also very common that applications have a specific application login, particularly web applications do this. And no matter what, ideally, these application logins or users should only have permissions that runs to procedures that also then perform permission checks, etc., etc., etc. But we all know that not all applications are written that way, so we may have no choice but then to grant select, insert, update, and delete permissions as well. But that's where it stops. Never give them all. And why? And the reason for this is SQL injection. Because if there is an SQL injection holding an application, and basically if there is an application, we can assume there is, things are that bad. I mean, of course, you can still do damage if you have these permissions. You can go and delete data. You can go and update data. You should not have permission to change, etc. But at least the damage is confined to the database itself. It cannot spread it to the rest of the server and the rest of the organization. That's very, very important. And by the way, if you have these kind of application login, particularly with these permissions, yeah, it can serve very well as the sandbox login if you prefer. Now, what if the application needs permission, after all, to do things beyond, because it's doing something advanced? And let's say, here's a simple example. We want to show in the application a count of how many users that are connected to a database. Well, this requires permission to use the DMV systemx sessions, which requires view server state or view server performance state. But then you can see all DMVs with that one and too many rows in that DMV as well. So that's not really a good thing. But what if we could, let's say we could have this idea, we could package this into this procedure and we have full control. But rather than granting the permission to the login, we kind of grant it to the procedure. What if we could do that? And yes, we can do that. It's a bit roundabout, it's a little complicated, and I will not have the time to show it. But the idea is this: you sign the procedure with a certificate, and from this certificate you create a user or a login, depending on which kind of, or depending on the database or a server level permission, and then you grant that user or login the required permissions. As I said, I don't have the time to show how to do this, but on my website there is an article called Packaging Permissions in the Procedure, which, oh, there's a question on screen. Can users without login be orphan users? Let's see, and then there's such, And slides and code are available for download. Yes, they are. And there will be a URL in the beginning, and I will come back to that at the end as well. The final slide will have that. Can they be security vulnerable? No, that's not the same as orphan users, well, kind of, but they kind of by design, because they cannot be connected to server users. And well, whether they can be a vulnerability, it's an interesting question. Any user could be a vulnerability. And actually, in this article, I show how a user without login can actually go and elevate to sysadmin, but that requires that you do some really bad things. But generally, no, I would say they are a really, really great option, because one of these things because again, if you don't need something on server level, why create something on server level? I mean, the less you create, the better. I hope that answers the questions. So, in this article, it's fairly long. It also includes a procedure and script to automate the process. It can be quite useful. And it is long, and one reason for it is long because I also tried not only the mechanics, but also how it works. Because I think using a security feature, particularly advanced security feature, without understanding how it works, it's not particularly secure, because then you might use it in the wrong way, and then you can create new security holes. Also, there is a video recording on YouTube. As a matter of fact, I did this session about this on Bits 4 years ago, but the recording is from another occasion, which is good because this one is longer. The one on Bits got a little bit cramped because of the 50-minute format. And also, I actually have an upcoming event on SQL Friday. That's an online event hosted by my fellow MVP and also Swedish guy, Magnus Ahlqvist. It's going to happen on noon, Central European time, and it will be 11 o'clock British time, April 14th, and there's a link that you can sign up on the meetup page. Here, I will only discuss some of the key facts that are interesting, why this is so powerful. So, when you change a signed procedure, the signature will go away, and the signature is the one thing that brings the permissions in. So that means that the permissions also go away. So every time you change it, you have to sign it. So let's say that Debbie comes up to you and says, oh yeah, I got this procedure, I want to show the user account. And you look at it and says, yeah, this is good, Debbie, I like this. So you sign it, and granting permissions, arrange all that, and everything is happy. But then Debbie gets the idea, now wait a minute, I want to do this as well. I want to do some naughty stuff. But then she finds that, wait a minute, it doesn't work anymore. So she comes back to you and you says, now wait a minute, Debbie. No way I'm going to agree to that. Restore the regular version, please. I'm going to sign that one, but no way I'm going to do that. So they cannot use these trick things behind your back. As a DBA, you are in full control. And what about permission hijacking specifically? So this is really, really interesting. I think this design is so clever. So when you sign the procedure and you invoke dynamic SQL, now the dynamic SQL is not part of the procedure technically. It's a procedure of its own. But yes, the permissions are available inside that one. So that means that, let's say you only want to grant permissions to run the procedures, but you want to do dynamic SQL. Then you can package the select permissions needed with the procedure rather than with the users. Also, if you, for some reason, call system procedures, yeah, they still carried on into these. But if you call a user-reading code, a sub-procedure, you fire a trigger or a function. No, the permissions packets that are being removed. They're taken away from the user tokens. So this means that you cannot be hijacked by triggers or procedures that you call unknowingly. What you sign is what you see. You are in perfect control. Well, one thing I like to point out, if they're doing dynamic SQL, wait a minute, how is that dynamic SQL being formed? Maybe it's coming from a source you don't have control over. Maybe it's being read from a table or a table name or something like that. Don't sign it. That could be bad. But apart from that, it's a really, really powerful thing. Now, I'd like to discuss agent jobs. So DevDave comes up to say, oh, you missed the DBA. Oh, we have this purge procedure. We need to run this one. Could you schedule a job for us that runs like 2 o'clock in the morning? And now if you be an autopilot, having lots of things that you do, and you go and schedule that job as sysadmin, you can see Debbie and Dave doing high five. Yeah, we're taking over the database. Because now they can do everything from that procedure. So no, of course, you're too smart to do that. Rather, you're going to lean over to Dave and say, look, Dave, couldn't you just schedule that with this task scheduler? I mean, after all, between you and me, agent is for management tasks. It's not really for application jobs, is it? But yeah, we may not win that battle, but we could at least we could try. So before I look at other alternatives, I just like to establish some general principles about agent. So I mean, I think no one disagrees with this. Job owners should not be persons who can leave the company. That can just cause troubles. It should be an abstract user of some sort. Also, I don't like adding users to MSDB because MSDB is a creepy place. You give user one little thing, and all of a sudden they could do this as well. So just keep them out as much as you can. Yeah, thank you. So therefore, setting up agent jobs that's always a sysadmin task. Writing the code that is being executed, that's for the developer, but you define, as a sysadmin, define the job. And also, I think this. Application jobs and agent, they should run with the same applications as application users because, hey, it's an application task, so what's the difference? And if they need to do more advanced things, for example, at the end of the month, you need to create a new petition, well, use signed procedures. That should be the mechanism to go. Now, so what other alternatives do we have to task schedule? Well, one is we can set the user on the job step. So down here on the advanced page of the job step, you can set run as user, app login, for example. And in this case, what's going to happen is that agent is going to impersonate that one with execute as user, which means that you are sandboxed into the database, so you don't make any cross-database access, you cannot access linked servers. But maybe if it's only a purge job, that will be okay. If they're going to archive data to a different database, it may not work out, but that could be a solution. If you do this, the job must be owned by sysadmin, or else this setting is just flatly ignored. The next alternative is to set the job owner, which you do on the first page of the job. And again, that should be a login with application permissions. It could be an SQL login or a Windows login, whichever you like. And in this case, agent, again, is going to do impersonation, but this time with execute as a login. So there's no sandboxing inside SQL Server. So that's no restriction, but linked servers with self-mapping is still not going to work out. Overall, linked servers with self-mapping is usually a problem even with agent running the whole as itself. And here is a nasty side effect of setting the job owner. The job owner will be added as a user to MSDB and the SQL agent user role. But it's not going to happen directly. No. It's going to happen the next time you install a cumulative update or a GDR. So I haven't tested, I think there was a new CO2 coming out just the other day. I haven't tested that one, but I will be amazed if they fixed it. With CU1 for SQL 2022, they still do this madness. I don't understand why, yeah. And the last alternative, it's the most complicated, but it's actually my favorite. It's doing a command exit job with a proxy. Because this is great because there is no impersonation, because agent will perform a real login into Windows. And there's no restrictions with linked servers for that reason. And what I said, it's the most complicated, it's also the most general. So first of all, you need to talk with AD people, say, hey, we need an AD account for this job going on. And then you create a login in SQL Server, and if there are linked servers involved, you have to create the login in all of the instances, of course. And then you create the database user and grant application permissions. And if you have an application user role, well, you would add this login to that role, of course. And then you create a credential in SQL Server. You say create credential, an Apple job runner, and with identity, with the Windows login. And Apple job runner is just an example, but typically you would use the username of the Windows user to keep things simple. And the secret is the password you got from the Windows login. And then you create a proxy in agent. So when you open the agent node Object Explorer, there are a couple of things, and one of these is proxies, and then you can select what kind of proxy, and it will be an operating system command exec. So then you're going to reuse the credential, and you have to give the proxy a name, and well, of course, you can call the credential Gretchen, and the proxy name, I don't know, Catherine, whatever. But why do that? I mean, the simplest thing is to use the same name. And then you create a job with agent with sysadmin as owner, and then you create the job step. Well, you set the job type to be command exec, not TSQL. You set it to be command exec. And then you set run as, because this run, when you do a TSQL step, is always empty. But here you have some selections. And what is going to happen now is that agent is going to retrieve from SQL Server the information about the credential and will get the username and the password. And then typically, you would run SQL command as your command shell stuff, and this is how the command would look like. You would have the -i option, because for some stupid reason, SQL command connects with the quote identifier off. This, by the way, does agent completely stupid. You need the -b option. It's very important, because if this command fails, you want that failure to propagate back to agents, so the job is seen as failed, and for that purpose you need -b. This thing that follows -s is to set the server name. It's a so-called agent token. The point we're doing this little more complicated thing is if you're going to move the job to a different server, you don't have to think about changing the server name. And finally, you give the database name and the command to run, which typically would be a stored procedure. Now, since we said that we don't want to add users to MSDB, this means that the developer's application team does not have access to the agent history. So how would they know if things go wrong, what has happened? Well, you set up mail notifications, so they get mail if the job fails, and also if they prefer, also if it succeeds. And then, on the advanced page of the job step, you can define an output file, but you can't do that if you went for alternative 3, because it only works if sysadmin owns the job. And then you will make sure that that output file goes to share where the developers have access, so they can see what happened. And if the job, so that you don't have to be involved if there was a failure. And by the way, using an output file is always a good idea, because reading the stuff in agent history and that box is not fun. And it's also often truncated. Now, so far, the attackers has been someone who's already been given access to the server or sneaked in through an SQL injection hole. But it turns out that you can perform these attacks even if you don't have access. I mean, so you get a deployment package of some sort from the application team. And when you think of it, it could include all sorts of nasty stuff. I mean, they could go and add extra logins of users because they get tired of every time there is a problem. They don't want to bother the user, oh, let's add a sneaky login so we can log in ourselves and check things. Or they can, steal data or do whatever stuff or in the database. Well, think about this. In the package, they set up a temporary linked server to another server where there is some really interesting data, because they know they are sysadmin on that server as well, using self-mapping, stealing that data, and then they set up another temporary linked server to a test server where they have access and dump the data, and then happy. Yeah, all sorts of evil stuff could happen. Now, how can you protect yourself against hijacking? Well, of course, execute as user DBO with no revert. Why? So this case, why do we need with no revert? Because, well, let's say you're running a script. And, of course, then you could sneak in revert command into that script. But with no revert, you're saying, no, I don't agree to that. So if there would be a revert, there will be an error. And if that happens, it's definitely all reason to sound the alarm, because that shouldn't occur. But if you do this, though, if execute as user equal DBO, that means you're saying that the application team is DBO now, even if you didn't add them to the database, because they will do so many things in the database, and it will be impossible for you to just keep track of what they're doing. So rather, you could use a sandbox user that you add to our DDL element, because you think they should only add code, they should not deal with users, anything like that. Or let's say if you have it's a vendor application, but which permits the customer to add procedures to a specific schema. Well, of course, then the sandbox login or user would only have permission on the schema. As a sandbox user, if they're doing things outside the database or they need to access linked service, well, of course, you would use a sandbox login instead. But and I would recommend if you do this, first do this stuff in QA, and see what happens. And there might be errors, because that may not reveal malicious actions, but because, let's say, they told you, yeah, we're doing things in the database, but then they forgot about that linked server, etc. So you can go and check that. And you might find that, oh, you're doing this thing on server level, which might be okay, because the server is dedicated to this one database. So it's okay that they're doing SP configure, but you might then say, okay, please give me these few privileged actions and a separate script so I can review them. But sometimes you might not have the choice, because they might be doing so many later things at server level that you don't really have control. Or you might get something like a DAC pack or MSI install, and you can't really look into what's in there, and it's unpractical for the developers to entangle that particular piece. Or you might even have the choice to choose the login. So how are you going to deal with that now? I guess auditing is the only option, and I don't want to go in and discuss how you would set up that audit, because that would take too much time. But when it comes to auditing, there are a couple of options you can do. Well, trace, extended events, SQL Server audit, event notifications, and DDL triggers. The one thing I like to call out is that SQL Server audit is about the only option that audits it has been turned off. Because if they are doing evil things, of course, they want to turn off the auditing. And particularly, I like to call out by DDL triggers that DDL triggers can be disabled with a disabled trigger, which does not fire DDL triggers. Yeah. So yes. Because, of course, if you see SQL Server audit, wait a minute, the audit was turned off, that's a red flag. Then just isolate that server and see what's going on. Yeah, so this is a summary of what I've been talking about. But, and then no questions on the screen. So, this is the whole idea. A user with some elevated permissions can lure you to run code unknowingly that abuses your permissions to run evil stuff that you will not agree to. And the means of protection is based on the principle of least privilege, POLP. So, personate DB0 to get rid of your server-level permissions, to protect DB owner from being hijacked, use sandbox users or logins, and never put people directly in DB DDL admin, but create a role like our DDL admin or whatever, and which you deny the rights to DDL triggers, because developers simply don't have any business there. Application users or logins should have limited permissions, never more than select, insert, update, and delete permissions. And application tasks and agent, again, the same thing. They should run with application permissions, never elevated permissions. And use procedure signing when that's a really great thing to use when application users need to do things beyond the permission set. Yes, and I referred you to a very long article, which is quite a bit of reading, but it is a really powerful thing. And keep this in mind, even if you don't give the developers permission to the server, they might still be equal to DB owner, all depending on how you run their deployments. So this is my final slide, but my name is Erland Sommarskog, and here's my email address. And again, slides and scripts are available on my website, sommarskog.se/present. This script is a cleanup that cleanups the things that were created in the demos. And here, the feedback link again, and here's the direct link to this article on my website. There's a few more things that I cover that are maybe a little more esoteric, but still, yeah, they could happen, that I cover here. And if you have any questions or comments, I will be very interested to hear. Or if it's just too early in the morning for... We have a few more minutes. Yeah. Thank you, Lewis. So, yeah. Oh, the check is in the mail. I mean, have you thought, was this something you had thought about before? No. I was actually the thing when I discovered this was when I was working with that other article where I do some DDL stuff with certificate signing, etc. And was thinking, let's see, is there any way that the database owner could use this? And then I was thinking, and then all of a sudden I realized, wait a minute, yes, the DDL could do this. And I was feeling really stupid. Because that's also the kind of the bad things with security. We have to think about the box to find the vulnerabilities. Well, if there's no more questions, I shall not leave you around, but just thank you very much for being here and hope you enjoy the rest of the day.